Hey everyone, welcome to Expert C# and .NET Programming video course by Pack Publishing. My name is Ronald Adolph and I've been a professional software developer over 15 years, and lots of that has been exclusively with .NET. Now I've worked with some like the big six consulting firms as well as smaller companies, but what's most fun to me is really teaching about code, which is what I've been focused on the last few years by being an author and a coach. So if you want to learn a little bit more about me, feel free to check out my website, ronaldadolph.com, or follow me on Twitter at ronaldadolph. This course will dig into key features that were introduced in .NET as well as the new version of C#. In this course, we're going to take a look at an overview of the .NET architecture. Then we'll follow up with new features of .NET 4.6, then an overview of Visual Studio 2015, followed by C# 6 new features. After that, we'll then begin building an application using some of these new features in C#, specifically a mortgage calculator. And then we'll finish up by discussing deployment and hosting by actually doing that. In order to get through this course, you should be familiar with some object-oriented programming principles, as well as some C# knowledge, and being a little bit familiar with Visual Studio. So let's go ahead and kick this journey off, and I will see you in the next video. Hey everyone, welcome to Expert C# 6 and .NET Programming Section 1, .NET Overview. So in this section, we are going to take a look at what .NET is and basically explain it. Then we'll talk about the common language runtime environment in addition to the framework class library. And then we'll follow that up with a deep discussion of the compiler, how it works, and all its different components. But for now, let's move on to the first video of this section that deals with .NET and explain exactly what it is. So in this video, we're going to take a look at what .NET is and then give a simple, very straightforward explanation. .NET is a software framework that Microsoft defines as a runtime execution environment that manages applications. So when we write code to produce applications, that program, that software runs on top of the .NET framework. And our program can use the services that the .NET framework provides. And those services can include cryptography, reading content from files, communication with databases, network communications, and so much more. So as a result, you're able to write applications that span an array of purposes, be it for games, business programs, websites, or mobile applications. Now, I like to think of straightforward answers rather than wordy ones. So for example, if you were asked in an interview what .NET was, I would answer it as straightforward as .NET is a managed execution environment that provides services to applications running on top of it. That's it. And if they wanted to dig in a little bit deeper, then that's when you can say that it's made up of two major components, the CLR and the FCL. And those stand for the Common Language Runtime Environment and the Framework Class Library. So that's it. In this video, we learned about what .NET actually is at a high level and provided a very straightforward explanation. Now, in the next video, we'll dive in a little bit deeper and actually discuss what's inside the intricacies of the Common Language Runtime Environment, the CLR, and also the Framework Class Library, FCL. I'll see you in that video. In the previous video, we looked at what .NET is at a high level. Now in this video, we're going to go ahead and take a look at two of its major components, the Common Language Runtime and the Framework Common Library. Earlier, we defined that .NET as being a managed execution environment that provides services to applications running on top of it. Well, the CLR is that execution environment for .NET applications. And those applications could be written in a variety of languages. If I'm to take you to a wiki site where we have a list of CLI languages, CLI standing for Common Language Infrastructure. We'll actually talk about that a little bit later on. But it is just a specification that languages need to adhere to in order for it to work in an environment such as the .NET framework. So these are examples of some languages, and C# just being one of many, that we could actually write code in that'll work in our environment. Now, besides being able to write code in many different languages, there's lots of services that the CLR provides. Some of them include memory management and garbage collection, type safety and exception handling, communication with the operating system and hardware, so that you don't have to worry about that. You don't need to worry about what version of the operating system that you're working with and whether or not it's going to be compatible with your application, and also compatibility issues with the CPU. So in short, the CLR assures your program works correctly, and if something goes wrong, it manages that error handling also, no matter what language it was written in, because it handles multiple languages. Now, you won't be dealing with the CLR directly. All that happens in the background. What you will interact with normally will be the frame class library, otherwise referred to as the FCL, which provides you functionality through a library of classes and interfaces that you'd otherwise have to write yourself. So it makes life a lot easier. Some examples of some functionality that it offers is encapsulating data structures, .NET framework security checks, reading and writing from a disk, access information about loaded types. So there's a whole host of functionalities that it offers, and it's essentially the reason why it's called a library. It's a library of resources. Now, at times you might hear about the BCL, which is just a stripped down version of the FCL. It has some, but not all, of the features of the FCL. Now, when writing applications, you'll be using parts of the FCL so that you can write desktop applications, web services, mobile apps. The FCL is huge, and hardly anyone is a master of all of its features. Usually someone might be an expert in one specific area, like creating desktop applications or maybe mobile applications, and leverage all the features related to those areas from the FCL. So those were the two very high-level components of the .NET framework, the CLR and the FCL. And in this video, we learned that within the .NET architecture, the CLR provides the execution environment for your application, and the FCL provides functionality for it. Now, next, we'll be looking at the compiler of the .NET framework, its guts, how it works, what's the flow of it. So I will see you in that next video. In the previous video, we looked at the common language runtime and the framework class library. Here, we're going to explore the compilation process. We're going to learn all about the compilers that's involved in the .NET framework. So we're going to be taking a look at the common language infrastructure, the common intermediate language, just-in-time compiler, Ryujit, and Roslyn. So let's first start off with the common language infrastructure. So we mentioned how .NET is able to be written in many languages. Well, this could be done because of the CLI, the Common Language Infrastructure. It's essentially an open specification developed by Microsoft and was standardized by ECMA. And it describes executable code and the runtime environment that allows multiple high-level languages to be used on different computer platforms. So think of it as just a set of rules that it sets, okay? So if we're going to be able to have the flexibility to code in either Visual Basic or C# or C++, all those languages need to follow certain rules. And that's exactly what the CLI specifies, such as making sure that there's going to be a common language that they're all going to be translated into, making sure that they all handle exceptions the same way, making sure that any of those languages have common data types. And any languages that conform to the CLI can compile to what's known as the Common Intermediate Language, CIL. It's going to be a lot of acronyms, so just bear with me. That CIL is also referred to as bytecode. So any languages that target common language infrastructure compatible runtime environments can compile to a common intermediate language. CIL was formerly referred to as MSIL, which just stood for Microsoft Intermediate Language. And you could think of it as really the lowest level human readable programming language. It's at the point where when you read the code, you can still make some sense of it before it becomes converted to the level where it makes only sense to a machine. CIL is assembled into an object code that has bytecode style format, but essentially we often refer to it as bytecode. And this bytecode is either translated into native code or executed by a virtual machine. So a quick overview. 4 steps we could take a look at. The source code, such as C# or VB.NET, is converted first into CIL. Step 2 is CIL is assembled into bytecode and an assembly is created. So if you were doing code from a DOS prompt and you use the C# compiler, which would be csc.exe to compile code, that creates an assembly, an executable code. For step 3, upon execution of that assembly, its code is passed into the JIT compiler to generate native code. And the final step is that the computer's processor executes the native code. So now, let's talk about the JIT compiler. But before we do, let's give a quick background of what the process is like. At a high level, source code such as your C# is compiled into bytecode, as we just said. Well, compilation essentially overall can be done either explicitly or implicitly. Explicit compilation converts the language into object code prior to the program execution. And the style of doing this would be referred to as ahead of time. And ahead of time compilers are designed to ensure that the CPU understands every line of code before any interaction takes place. Now, implicit compilation is a 2-step process. The first is that it converts source code to common intermediate language, CIL, and that's done using a compiler that's like a built-in, such as if you're coding in C#, the csc.exe executable. The second step would be converting the IL to machine instructions, and that's done with JIT. And when I say IL, we're still referring to the CIL. And I specifically use that term because sometimes when you're reading .NET documentation, they might be referring to IL, but that's just still short for CIL because we're talking in the context of .NET. The last thing to note is that only executed fragments of the intermediate language code are compiled at runtime. So when we talk about JIT, keep in mind that it's part of the Common Language Runtime, the CLR, and it eventually produces the native code. So a quick recap. During compilation time, the source code is compiled to exe or DLL by the .NET compiler, such as csc.exe. Where you see the exe DLL, the Common Intermediate Language consists of instructions that any environment supporting .NET can execute, and that includes metadata describing structures of both data and code. And during runtime, the JIT compiler processes the CIL instructions into machine code specific for an environment. So having said that, there are 3 JIT compilers and approaches to compilation. The first is the normal JIT compilation, and that implements the implicit method that we mentioned earlier. The second is the econo-JIT compilation, and that is almost like a hybrid, so it's not necessarily specifically implicit or explicit. But the third is pre-JIT compilation, and that mirrors explicit method we discussed earlier. Normal JIT complies only to those methods that are called at runtime. These methods are compiled the first time they are called, and then they are stored in cache. When the same methods are called again, the compiled code from cache is used for execution. Econo-JIT compiles methods when called at runtime and removes them from memory after execution. And the last compilation form is pre-JIT. It compiles the assembly instead of use methods. In .NET languages, it is implemented with NGen-exe, the native image generator. All CIL instructions are compiled to native code before startup. This way, the runtime can use native images from the cache instead of invoking the JIT compiler. So we talked about JIT. Now, what I'd like to mention is that there is actually a new version of the JIT compiler, and it's called RyuJIT. It's a new 64-bit JIT compiler for .NET 2015. A little fun fact, in the Japanese language, Ryu means dragon. And so RyuJIT actually stands for Dragon JIT. The new JIT is supposed to be 30% faster at startup, and it's based off the same code base as the original JIT, so there should be less likelihood of having any bugs and compatibility issues. There's also a new compiler platform, and it's by the name of Roslyn. Roslyn provides an open source C# and Visual Basic compiler which has rich code analysis APIs. It basically enables code analysis tools with the same APIs that are used by Visual Studio. So if you were coding and needed to be able to leverage the ability to use IntelliSense in your code, this would allow you the API to do that. So there's actually several sections to the APIs. There's one specific for features, there's one for the workspace, and there's one specific to the compiler. And you can dig in a little bit deeper on GitHub because it's open source. There's documentation that details all of that information. So a little clarification between RyuJIT and Roslyn. Just keep in mind that Roslyn converts code like C# to CIL, the bytecode. So it essentially would replace the executable CSC, which is what Visual Studio uses when you compile your code. CSC would be the compiler for C#. However, RyuJIT at runtime converts the IL that is created by something like Roslyn or CSC.exe and converts that into native code. RyuJIT replaces JIT. So in this section, we had a .NET overview, and then we discussed the common language runtime, followed by the framework class library, and then began a discussion on the compilers, which included talking about the common language infrastructure, the common intermediate language, just-in-time compiler, as well as RyuJIT and Roslyn. In our next session, we'll dive into the new features of .NET Framework 4.6, and I will see you there. In the previous section, we had an overview of the .NET Framework. In this section, we'll learn some of the more important features in the new version of the .NET Framework 4.6. In this section, we're going to go ahead and take a look at enhancements in cryptography, ADO.NET, Windows Presentation Foundation, Windows Workflow Foundation, profiling, and the new native image generator. For now, let's start off with cryptography, the support that's been added for X509 certificates containing ECDSA. That's what we're going to go ahead and take a look at in this video. First, a little quick background. Cryptography is a practice and study of techniques for secure communication. More generally, cryptography is all about protocols that prevent third parties from reading private messages. Now, digital certificates are used to prove identity as an authentication method and distributing public keys stored in the certificate. These keys are generally associated with one owner. And data in the certificate is hashed, and often RSA is the algorithm that's used. And it's important to note that, because the standard used to create certificates is called X.509. So now we could talk about what's new, which is that the .NET Framework has added support for ECDSA X509 certificates. And ECDSA stands for Elliptic Curve Digital Signature Algorithms. And it provides better performance and is a more secure cryptography algorithm than RSA. It's also fairly straightforward to implement. Before we had the support for ECDSA, in your code what you had to do is require using a cert.handle and a series of P invokes to get an underlying key, and then passing that to a CNG key object, and then passing that to a new ECDSA. Basically, it was like a lot of work. But now with the support, you can just define the ECDSA private key variable assigned to a value you get when invoking getECDSA private key. And at that point, invoke signed data after passing the data and hash name. It's a lot shorter and cleaner. So in this video, we had an overview of cryptography and certificates, and then discussed the new support for ECDSA in X509 certificates. Up next are the new enhancements in ADO.NET. I'll see you there. In the previous video, we looked at new cryptography support features. In this video, we're going to go ahead and take a look at some new features in ADO.NET, specifically the always encrypted support that's been added, and also the improved multi-subnet failover. There's a new feature called always encrypted, and this feature ensures sensitive data is never seen in plain text in an SQL Server instance. Always encrypted allows client applications to encrypt sensitive data without revealing the encryption keys to the database engine, so that data can't be accessed either in flight or at rest. Even if the SQL instance of the host machine is compromised, all an attacker can see is ciphertext of the sensitive data, which will mean nothing to them. The always encrypted feature was designed to protect sensitive information such as your credit card numbers or your social security card numbers that's stored in a SQL database. So what's new? Well, ADO.NET now supports storing always encrypted column master keys natively in hardware security modules, also known as HSMs. Now with this support, customers can leverage asymmetric keys storage in HSMs without having to write custom column master keys store providers and registering them in applications. So basically, it just makes it easier to set up hardware security. Another feature that got enhanced was always on availability groups, which is defined as a high availability and disaster recovery solution that provides an enterprise-level alternative to database mirroring. It was introduced in SQL Server 2012, and this always-on availability groups feature maximizes the availability of a set of user databases for an enterprise. And what's new in this feature? Well, there's improved multi-subnet failover connection behavior for always-on. So let's look at the word multi-subnet failover. What exactly is that? Well, a SQL Server multi-subnet failover cluster is a configuration where each failover cluster node is connected to a different subnet or different set of subnets. So going deep into that is beyond the scope of this course, but just know that basically the SQL client now automatically provides faster connection to an always-on availability group. Personally, I wish they came up with better names and always-on availability group. It's kind of like a mouthful, but that's what we got to work with, so it is what it is. So in this video, we got to look at some new ADO.NET features which involve the new support for always encrypted, in addition to the improved multi-subnet failover. Coming up next, new features related to Windows Presentation Foundation, WPF, and Windows Workflow Foundation, WF. I'll see you there. In the previous video, we looked at what was new in ADO.NET. In this video, we're going to go ahead and take a look at some of the new enhancements in Windows Presentation Foundation, WPF, and Windows Workflow Foundation, WF. Now, if you look up what Windows Presentation Foundation is, it'll say on Microsoft's site that it provides a unified programming model for building modern line of business desktop applications for Windows. It's really just a fancy way of saying this is what we use for building Windows applications now. They used to use forms, but now they use this new way of developing Windows applications, implementing XAML. If you look at the bottom right-hand side of the screen, that XML syntax is what's referred to as XAML. Right above it is where you would put together the GUI of the application, and on the left-hand side is your toolbox where you can choose the controls that you want. So what's been changed? Well, there's been some improvement in performance. The delay in firing touch events has been fixed in the latest .NET framework. And in addition, typing into the rich text box controls no longer ties up the render thread during fast input. There's also been some spell checking improvements. The spell checker in WPF was updated as of Windows 8 to leverage the operating system support for spell checking additional languages. Also, now there's additional support for per-user custom dictionaries. So now in the .NET framework, WPF recognizes custom dictionaries that are registered globally. And this capability is available in addition to the ability to register them per control. In previous versions of WPF, custom dictionaries didn't recognize excluded words and autocorrect lists. So now let's look at Windows Workflow Foundation. If you haven't used it before, Microsoft defines it as a technology that provides an API, an in-process workflow engine, and a rehostable designer to implement long-running processes as workflows within .NET applications. So if you look to the image to the right here, you'll see that when you're putting together a Windows workflow application, you're actually going to be engaged visually by putting components together that shows through the UI here of the IDE the flow of your application, which is kind of cool and different. So what's new? Well, now we have this enlist promotable single phase method, which can use a distributed transaction manager other than the MSDTC. And the MSDTC is just an acronym for Microsoft Distributed Transaction Coordinator, which was the default. That's what you had to use before, but now it's not the case. You're not limited to just that. Essentially, it was a Windows service providing transaction infrastructure for a distributed system. So what's important to know and get out of this is that you're no longer restricted to just using the MSDTC. And just for some clarification, distributed transactions ensure that changes to different databases happen either in all of the databases or none. And now actually Azure SQL Database now supports the system.transaction APIs using non-MSDTC coordinators. So basically the new features that I mentioned also applies to Azure. So in this video we got to review some of the enhancements that apply to Windows Presentation Foundation as well as Windows Workflow Foundation. Coming up next are enhancements to profiling as well as the new native image generator. I'll see you there. Hey everybody, welcome back. Now the last two new features in the .NET 4.6.1 framework that I'd like to hit on are related to profiling and the native image generator, specifically the unmanaged profiling API and the native image generator PDBs. PDBs standing for program databases and native image generator often referred to as engine. Now many of us are probably familiar with the task manager. Sometimes you need to check to see how much memory is actually being used or how much of your CPU is being absorbed. It's a default profiler, okay? Well, you could build your own profiler like this and access some of the performance details, and some of the developers do as part of the applications that they're building. Accessing assemblies and PDBs is part of the process though. Now it's important that I emphasize accessing assembly because in later versions of ASP.NET, it's becoming much more common for assemblies to be compiled in memory by new compilers such as Roslyn, which we talked about earlier in the course. For developers making profiling tools, this means that the PDBs that historically were serialized on the hard disk might not be present. Profiler tools often use PDBs to map code back to source code lines for tasks like code coverage or line-by-line performance analysis. But now, the good news is that part of the unmanaged profiling API has the new iCore Profiler Info 7 interface. So, by using it, a profiler could obtain the contents of an in-memory PDB as a byte array and then process it or serialize it to disk. And that makes life a lot easier if you're building a profiler. Now, another enhancement is related to an interface called iCore Profiler. Profiles that are using that interface's functionality for dynamic instrumentation could now modify metadata. That couldn't have been done before. Previously, tools can do some instrumentation to the IL at any time, but metadata could only be modified at module load time. And because IL refers to metadata, this limited the kinds of instrumentation that could be done. So Microsoft lifted some of those limits by adding this new interface that allows you now to modify metadata, which is pretty cool. While on the topic of profiling, with the new native image generator, there's a better experience with cross-machine event tracing. And all that term means, cross-machine event tracing, is that it allows an individual to profile a program on machine A and look at the profiling data with source line mapping on machine B. The experience is a little bit better now, but in the past, in previous versions of the .NET framework, the user would copy all the modules and native images from the profiled machine to the analysis machine that contains the IL public database to create the source to native mapping. This was a long process, but now the new native image generator can speed up the process by creating a public database that contains the mapping without a dependency, thus using a much smaller public database, which speeds up the copying process from one machine to the other. These features are advanced. You might not have to be coding to build compilers or profilers often, but it's nice to know that when you're ready to, you'll have a lot more flexibility with these new enhancements. So in this section, we've covered quite a bit of new features. Features that were related to cryptography, ADO.NET new features, WPF, Windows Presentation Foundations, and Windows Workflow Foundations, in addition to profiling and the new native image generator. Coming up next, we'll check out what are some of the new features in Visual Studio 2015. I'll see you there. In the previous section, we covered some of the new and interesting features in the .NET framework. Now in this section, we'll be learning about the new features in the IDE, Visual Studio 2015. So there's been a lot of new changes in the IDE of Visual Studio. In this section, we are going to take a look at a few key ones. The first is the new light bulb. Then we're going to follow up with the discussion about refactoring and renaming, how that improves our productivity. And then we'll close with a talk about the debugging improvements that we now have. So let's go ahead and move on to the first video of this section, which talks about the new light bulb feature. And the best way to discuss this is through a demonstration. So why don't we go ahead and start with the demonstration within Visual Studio. The light bulb in Visual Studio allows you to perform certain actions and gives you a preview window before executing changes. So if we were to hover or click on the directives that aren't needed, you'll notice that a light bulb shines. Right now I'm hovering on line 4, and you can see a little light bulb right here. So now if I were to click the drop-down arrow, a preview window will pop up. And this is essentially a view of what will change if I were to continue. Everything you see highlighted in red would be removed, and what's not highlighted would be left alone. Now you'll notice at the bottom is a section called Preview Changes. You can select Document, Project, or Solution. This essentially gives you control of the scope that the IDE should consider for the changes. So if I were to click Solution, it'll show me all areas of the solution and all files that'll be affected by the change. And when I click Apply, it goes ahead and removes the directives in the entire solution. Now notice also that after applying the changes, you'll see a colored bar next to the numbers that appears where the changes took place. If you recall, in Visual Studio 2013, when you needed to import a namespace, you could use Control Dot as a shortcut. And it's the same here also. However, now the light bulb comes into play. So let's go ahead and remove the one directive that we have here. I'll delete that and click Save. And now Visual Studio starts to complain. But as soon as I hover over it, the light bulb shines, and I have an option to click that drop down arrow again and then choose the using statement from here that's applicable. Or if I were to not hover over it and just navigate down with the cursor key, hold the control key and hit the period key, the window to import the using statement still pops up, except now it comes up with the features of the light bulb. It really feels to me that the overall theme when rebuilding this version of Visual Studio was simplification. And the light bulb really does add to that effort. So in this video, we briefly explored the new light bulb feature. Just keep in mind that this is a new productivity feature, so it's there to help you save some time. And in Visual Studio, there's so many different things you could do. I try to allocate at least 1 minute or 2 minutes a day trying to do something new that I haven't done in it before. And over time, it gradually accumulates and indirectly improves my productivity. So you might want to try that approach, or maybe you have another. But do keep in mind this is all for productivity, so yeah, it seems kind of cool to do, but overall it really helps save time, and that translates into money in the long run. Alright, coming up next, refactoring and renaming in Visual Studio, different ways of doing it in a more improved manner. I'll see you there. In the previous video, we looked at the new light bulb feature. Another great feature added is how Visual Studio handles renaming of variables, that is, refactoring. In this video, I'll be looking at how refactoring has changed with C#6, specifically when renaming variables, demonstrating how Visual Studio manages namespace conflicts, and lastly, controlling the scope of the changes I make. In the past, when renaming, you'd have to use a pop-up to handle it. Here I'm in an old copy of Visual Studio 2013. If I wanted to rename a variable, such as the runners, I can right-click and select Refactor and then choose Rename, and this pop-up will show up. Well, in 2015, the pop-up is no more. If I right-click on the runners and select Rename, it will select every instance of the runners in my code. It'll exclude comments and strings, but if I want to include that, on the right-hand side I have a small pop-up where I can select Include Comments and Include Strings. And if I want to preview where all the changes are going to take effect, I'll select Preview Changes and then Apply. But before I hit Apply, let's go ahead and actually change the variable. I'm going to change it to the term the athletes. And I'm specifically choosing the athletes because that variable already exists. And what I want to show is how Visual Studio will recognize that the variable the athletes already is present on line 25. And because it's present, what it'll do is specifically put in the name of my class as a prefix before the variable I just changed the name to. So the term program is right before my variable. And program, if we scroll up to the top, we'll notice is the name of my class. Now with that change, if I go ahead and select Apply, we'll get that preview window, which will show every instance of the changes that are going to be affected. And I could simply choose Apply, and that'll be done. These changes are really just scratching the surface of the updates made to the IDE, but they're what we need to understand before diving into a more advanced feature enhancement such as debugging improvements. That's up next. In the last video, we looked at what was the new process of refactoring that was introduced in Visual Studio 2015. That is, modifying and changing code. In this video, we're also going to look at how we can change code, but it's going to be during the process of debugging, while the debugger is live. And that's all due to the new Visual Studio debugging improvements. Let's open up Visual Studio for a demonstration. So one of the neatest features I'm excited about is the enhancement in debugging, specifically editing code as you step through the debugging process. Now, the ability to edit code while debugging in Visual Studio has always been around for a while. However, they didn't support many new features that kept being added to C# on newer releases of it. But now that's changed. In Visual Studio 2015, the Edit and Continue feature has been rebuilt from the ground up to allow much more flexibility. Let's go ahead and show you how. On line 17, let's go ahead and put a breakpoint there. And to start the debug process, click the Start button at the top of the screen. Once that's done, go ahead and click the Step Over button at the top of the screen. It's a curved arrow. And go only to line 20. So now I'm going to go ahead and create a collection, specifically a collection of athletes. So set up a generic list of a type of athlete. And then I will populate it. But before I do, what I'd like to show you is that if I put my cursor on athlete and hold the control key down and hit period, I get an option to allow me to generate a class for athlete. I couldn't do that before. This is part of a new feature. So let me go ahead and choose that, generate class athlete, which is the second option, not the first where it creates a separate file. So if I scroll down, you'll see that a class was created right there. That's pretty cool. And we are still in the debug mode. So now let's go ahead and populate it. Populate this collection. And we will first create an athlete with a name of, let's say, Bo Jackson. And he'll have an age of 55. And let's say his favorite food is Italian. All right. And keep in mind, we are still in debug mode. So now if we click on name, hold the control key down, period, have the option to generate a property for athlete name. I click that, and boom, right below is a property within the class that we created earlier for name. And we can do the same for age, control period, generate property athlete age. If we scroll down, there it is. And now what we're going to do is not favorite food, but let's do food, because when I hit control period, I'm going to want to choose generate new type. And the type is going to be of type enum. Sometimes it defaults to class. Make sure that the kind is enum. Everything else should be the same for access and the location. So I'll click OK. And right below, you'll see our enum type. So now we can click on Italian, control period, generate enum member. And we can assume that that will be there. Let's go ahead and do favorite food for property. Generate a property, athlete favorite food. And now let's scroll down and check. There's our favorite food property. And there's our member, Italian, in the enum of food. So now if we take the arrow that's on the left-hand side, the yellow arrow, put the cursor over it, and drag it up carefully to, for me, it's line 19, we'll be able to actually step over it by clicking the Step Over button, and then hovering over athlete, you could see that the count is 1. And if you click on the first item in the collection, boom, you got the age, the favorite food, and the name, all in debug mode. Now I'd like to add another athlete. So just to keep it neat, I'll bring this curly brace up, add a comma, and I'll create an athlete, let's say Michael Jordan. And we'll say his age is 59. And his favorite food is Japanese. And so now we should go ahead and add a property for Japanese, a member in our enum class. Make sure that's there. And there you go. And now if I drag the arrow back up to look, I'll probably get a warning because it's the second iteration that there you go, edits were made because we made a change before. So I'm going to go ahead and click restart, but I'm still in the debug mode. Drops me back here, and as I step through, I have a count of 2. So we know we have both of our athletes in there in the collection of athletes. That's great. Now there's one more thing I'd like to show you, and that is how we are able to query a collection while we are in debug mode. So if you put your cursor on line 29, hit enter a couple of times. Let me scroll up so you can see that we're still in debug mode. I'll go ahead and create a variable. Let's say who loves Japanese. So let me build a query, a LINQ query from A in athletes where favorite food is equal to Italian. And select that. So return anyone whose favorite food is Italian. Right there. Boom. Looks good. Doesn't look like the code is complaining. And I will take the yellow arrow and drag it up now to line 30. And then I will move to the top and step over. And if we just look at the bottom here, there's the autos windows. You can see right there the result. And if you click on who loves Japanese and results view, we see our item that was returned, and there you go. Bo Jackson likes Italian food. And this is really good because there are sometimes you might want to just make some small modification while you're coding and you're doing it in the debug process, and this will make it a lot more convenient to do that, whereas before it would just crash. And that's it for editing while debugging. In this section, we took a look at some of the major features that were introduced in Visual Studio 2015, such as the new light bulb, the way Visual Studio handles refactoring and renaming of variables, and the new improvements in debugging. In the next section, we'll take a look at some of the new features that were introduced in C# version 6. I'll see you there. Hey everybody, welcome to section 4, where we are going to be exploring the new features that have been introduced in C# 6. Some of these features that's going to be included in this section that we're going to be reviewing includes the new using static clause, expression bodied function members, auto property, null conditional operators, string interpolation, name of expressions, index initializers, exception filters, await and catch and finally blocks, and lastly, how extension add methods work in collection initializers. The first topic that I'd like to go over is the new using static clause. And the best way to do that is through a demonstration. So let's go ahead and launch Visual Studio and get started. Chances are you're already familiar with the keyword using to handle disposing of objects when dealing with a particular resource, or when simply importing namespaces. Well, we can now use using in conjunction with the word static to import static members of types into scope. Let me show you an example. If we jump down to line 17 in our method test_using, you'll notice that we invoke the writeLine method on the static console class. Well, with the new version of C#, what we can do is at the very top enter in using static and then reference system.console. And so now, if we scroll back down to the bottom, you'll notice that console is slightly faded out. Now, if we move over to the right, we have the math class. We could do the same here also. So if we go to the very top and add using static system.math, math is also faded out, meaning that we really don't need to explicitly specify them. So if we click on math and hit Control period, we can simply hit simplify member access and it will remove that. So essentially we could do the same thing for console. I'll just hit the delete key to remove it now. And basically now, since they're already in scope, we don't need to reference them. So it keeps your code a lot shorter and cleaner, especially if you have a lot of classes that you reference that you could import by using static clause. And just to prove that it works, I can just hit Control F5 to run the program, and there you go. The concert was cool, tickets were $29. So we just reviewed how to use the new using static clause. And this is really a great feature that allows all the accessible static members of a type to be imported. So keep that in mind to make your life a little bit simpler. Coming up next, expression-bodied function members. I'll see you there. Hey everyone. So we just learned about the new using static clause. In this video, I'd like to introduce you to another feature called the expression-bodied function member. So let's go ahead and start a demonstration by launching Visual Studio and get right to it. Expression-bodied function members permit methods, properties, and other function members to have bodies that are expressions instead of statement blocks, similar to Lambda expressions. They basically permit methods, properties, and other function members to have bodies that are expressions instead of statement blocks, kind of like Lambda expressions. We have 4 different examples here in our code. The first is a property of a name, William Shatner. The second is a method returning a string, and that method returns 2 parameters, the first name and a last name. Our third method also takes in 2 parameters, first and last name, but it returns nothing. It's just a void. And the last returns an object, the object of singer. Let's go ahead and run this to see the output. And it writes out all of the names as we expect. By the way, to run it, all I did is hit Control F5. So now let's go ahead and modify the code to use expression-bodied function members. We'll start it with the first. Let me go ahead and comment this out. And for the first example, all I need to do is type in static public, and then string with the property name, hit the fat arrow, and I will enter in our singer, William Shatner, which, by the way, he is actually a singer and had an album put out years ago. But that's it. Much shorter, succinct, and much easier on the eyes. Let's go ahead and do our second example. We'll start off the same way. As a matter of fact, what I'll simply do is just comment this out, but I also copied the portion of the first line with the method name. And now we'll add in the parameters, first and last name. I'll add our fat arrow and use a new feature called string interpolation, which we'll talk about later on, but it's simply a way of entering the variable name within quotes. I'll do that for first name and last name. And enter. And just to keep things clean, I'll go ahead and get rid of what we've commented out. So now we'll move on to our third example, and I'll copy part of the first line again to start me off. Static public void, and the method name, print full name. We'll add in the parameters, add our fat arrow, which is another term for goes to, and here we'll put in console dot write line and then our output, which we'll just copy right from the top here. Let's see why it's complaining. Well, it's simply complaining because we now have a duplicate. So let's go ahead and get rid of our original method. And there you go. Print full name, pass in our two parameters it goes to, and then the output code. All right, now let's go ahead and move on to do our fourth example and convert that into an expression body function member. So let's once again get part of the code that we need to start off. And actually this, we could also include the parameters. And now the only difference is that we are dealing with an object, singer. So we have our print singer name with the parameters goes to, and since we're dealing with an object, new singer, and pass in the parameters that we care for. First and last name. And it's complaining because these parameters actually need to match. First name, last name. And there you go. Stops complaining, looks good. We'll get rid of our excess commented out code. And there you go. Our code is much more succinct, shorter, and once again, easier on the eyes. Might want to add a space between first and last name for these two. And let's go ahead and run it to see what the output is, make sure we don't have any issues. And there you go. William Shatner, Barbara Streisand, Bill Manning, and Ronald Dolph, all our singers. And that's it for expression-bodied function members. So we know that Lambda expressions can be declared with an expression body. And that essentially was the inspiration for the expression-bodied function members, which now brings the same convenience to function members of types. Coming up next, new enhancements with auto property. I'll see you there. Hi everyone. In the last video, we took a look at the new feature called expression-bodied function member. In this video, we're going to be taking a look at the enhancements made with auto property. So let's go ahead and jump into a demonstration to get started. If you're a fan of auto properties, you'll pretty much appreciate auto property initializers. Just as the name implies, you can initialize auto properties' default values with a little less work than you did in the past. Let's take a look at our singer class. In previous versions, if we wanted to assign a default value, we need to write a constructor like this. For writing constructors, I like to write the short abbreviation CTOR and hit the tab key, and boom, it brings up a constructor. And if I wanted to add a property of name, in the past, we'd have to do it like this, a great singer. But now, with auto property initializers, what I could simply do is just take this name value and basically assign it to the property down here, and then actually just get rid of the constructor. And what's going to happen is the compiler behind the scenes will assign that value to a backing field, making your life a little bit easier. And this might not seem like a huge deal, but in the long run, this definitely saves time, especially as the quantity of your code enlarges. So definitely keep this feature in mind moving forward. So in this video, you learned how to use auto property initializers to be able to set default values without having to use a constructor. Coming up next, null conditional operators. I'll see you there. So in the previous video, we took a look at auto property and its benefits. In this video, we are going to take a look at null conditional operators. So let's go ahead and start with a demonstration. Sometimes checking for null can become really tedious, but now we have the null conditional operator, which allows you to reach members and elements only when the receiver is not null. Let's show a typical example of how we would check for null before C#6. Above, I have a collection of singers. If I wanted to check how many singers are in the collection, I can create a conditional operator by first setting a nullable int and say number of singers, and then do a quick check to see if singers is null or not. And if it is, by using the classic conditional operator, we'll return null. And if it's not, we'll return the count. That's how we would do it before C#6. But now what we can do is simply start off the same way, defining number of singers. But all we need to do is enter singers and check to see if it's nullable by adding a question mark and then hitting the period and invoking count. We'll comment out the first line, and it's much shorter. If it is null, it will short circuit and return a null right away. So we don't even need to write all this extra code that we did on the first line. And if it is not null, it'll return the count. Let's go ahead and write this to our console. And when we run it, we get the number 2 because we had 2 singers in our collection. The other thing that I'd like to show you is that we can also use this method to get the first item in a collection. So for example, if I wanted to get the first singer in our collection, I can enter in singer, and let's write down default singer as a variable, which is equal to singers, and then check to see if it's null, and if not, return the first item. So let's go ahead and write that out to our console, and we'll enter default singer name is, and pass in the variable default singer dot name. Again, we'll hit on string interpolation later on, but this is no different than if we had just used this variable at the very end here, like this, and it got rid of this $, which is how we did it in the old school method. As a matter of fact, I'll leave it like this for now. And if we run it, the default singer name is Kenny Rogers. Now I'd like to show you something else. If I go to line 22 and get rid of our collection and set it to null, what do you think is going to happen when we get to line 29 and 30? Will it crash on 29 or will it crash on line 30? Let's go ahead and step through it by debugging. When we run it, we can step over 29 without any problem, and when we step over line 30, it crashes. We get an object reference error. And the reason why is because default singer is null and we're trying to reach its property. But what we could do to fix that is simply add a question mark to check whether or not it's null. And now if we run it, it runs right through without any issue. Now, even though it doesn't crash, it doesn't provide any value either. And it's just a blank for the name. The other thing that I'd like to show you is that the null conditional operator could conveniently be used with the null coalescing operator. That is the 2 question marks. And that will allow us to provide a default value when we're running into a null object. So for example, I can write a variable, the count, and say if singers is null, do not go any further and return me the value of 0. However, if it is not null, then return me the count. So now what I can do is write out to the console the value of the count. And when we run it, we'll get the count is equal to 0, which makes sense because we set our object of singers, our collection, to null. But if we were to repopulate that and then run it again, then we'll get the count is equal to 2. So once again, this is a lot easier to read and a lot more straightforward than how it was before. One more thing I'd like to show you is that if you need to check for null more than once, there's no issue with chaining. Let me demonstrate by writing default singer, check for null, and if it's not null, write the name is age, and this is where I'm going to demonstrate chaining. I'll add our collection of singers, check to see if it's null. If it is not null, return the first item in the index. And at this point, check to see if the age is null, and if it is not, return that. So let's do a little cleanup and comment out these lines that we don't need, and just leave the line where we define default singer. And now let's run. Control F5. Default singer, Kenny Rogers, is age 54. And that is it for null conditional operators. In this video, we learned that because sometimes code tends to get bogged down with null checking, this new feature, the null conditional operator, lets you save time by accessing members and elements only when the receiver is not null, to lessen the syntax that you need to write in your code. Continuing with this theme of simplification with code syntax, our next video will deal with string interpolation. I'll see you there. Hi everyone. In the previous video, we looked at and learned about null conditional operators. In this video, we are going to learn about string interpolation. So let's go ahead and start up Visual Studio and do a demonstration. String interpolation allows you to manipulate strings in a more concise manner than the old-fashioned string format, which tended to be error-prone, especially if you had to keep track of multiple placeholders. On line 26 here, you'll see that we have 3 different placeholders for city, state, and zip. But what if we had 5 or 8 or even more? Then it would become a little bit trickier to keep track of them. Let's go ahead and run this to take a look at the output. And there it is. It shows the addresses we expect. So now let's go ahead and rewrite this using string interpolation. I'll just copy and paste the old code and comment it out, what we had previously. And let's go ahead and rename this to new school. And the difference that we're going to make is instead of using these placeholders that we had before, we're going to replace them with the variable. But in order to do that, for C# to recognize it, we need to start off the string with the $sign. So then it knows that what's going to be in the curly braces are going to be variables. So we can now enter city, state, and zip and get rid of what we had here, including the parentheses that's closing and the beginning parentheses, and of course string format, because that is what we are no longer using. And that is it. So now if we run the program, we should get exactly the address as we did before. So much more straightforward, and it really is the way that it should have been designed in the very first place. Similar to string format, we can also use string interpolation to format the date or currency whenever we need to. So for example, if I wanted to use the variable cash that's on line 24 and print that out, make sure that it comes out in a dollar format, I can simply enter in a variable cash owed, and start off the same way with $, and say in my string today, and we'll put in curly braces a date time of now, and set that to too short date string, and write dollars owed, and in curly braces our cash, and specify we want it formatted as currency. And that essentially does the same thing as if we had used a string format and specified C for currency. So we could simply write this out now, and when we run it, we see our date and the dollars owed written as $15 in the currency format. Now you'll notice that I did use too short date string format here, but to do the exact equivalent of using a format specifier, we can simply have done this, date time now, and use D. And there's actually a chart on MSDN that has all the different format specifiers that you can use. So just Google standard date and time format strings. If we now run this, it returns the same output with this short date format string. And that is all. In this video, we learned about string interpolation, which lets you put expressions right into the string literal rather than having to put it all at the very end, which is how we've been doing it for years. It's a little bit easier on the eyes to read and just seems more logical. In the next video, we'll look at more enhancements of this nature with name of expressions. I'll see you there. Hi everyone. In the previous video, we took a look at string interpolation. In this video, we're going to learn about name of expressions. Let's go ahead and start by explaining what the name of expression does and looking at a demonstration. When refactoring, there'll be times you might want to change the name of an identifier like a property, class, or variable. And if the identifier is referenced in a string, Visual Studio will ignore it, just like it did here by not changing the term the fans on line 27 to the followers. And this will happen if you forget to check include strings. And if you're throwing in exceptions like we are here, passing in the incorrect name is going to cause problems and make debugging a lot more difficult. But here's the thing, even though we have the option to check include strings, if we're dealing with an identifier like a property, class, or variable, there's a better way to handle it. And that's when the name of operator comes into play. Using the name of operator makes refactoring easier because when you're using the name of an identifier, the compiler recognizes it. And to use it in this case would be to simply type in name of and in parentheses the fans. So now if we rename this, Visual Studio will recognize it and change it to the followers. And what's great is if we did enter in incorrect misspelling here, the compiler will complain because it'll say, hey, I don't recognize a variable called the followers X. A couple more things I'd like to note. If we had a variable called a fan and we tried to reference it here, it wouldn't recognize it because it's out of scope. The name of operator works with variables that are in scope. But if I were to take this and bring it into scope, then it won't complain. Now, the other thing I'd like to point out is that the name of operator will not work within comments. So for example, if we added this here and we tried to rename, it would not change. So the best thing to remember in this case is to check include comments. And that's it. In this video, we learned that the name of expressions are essentially a fancy kind of string literal where the compiler checks that you have something of the given name. And Visual Studio now knows what it refers to, so navigation and refactoring will work. In the next video, we'll be learning about enhancements with index initializers. I'll see you there. In the previous video, we learned about name of expressions. In this video, we're going to move on to index initializers and learn about what that is. So let's go ahead and start a demonstration. You're probably familiar with object initializers that permits you to assign values to fields or properties of an object. Well, index initializers extend object initializers so that you can now initialize not only members, but also the indices of the new objects. So let's take a dictionary object, for example, and show the old approach and then the new. This is the standard way of initializing a dictionary. Let's copy this and rewrite it to the new approach. So the major change that we're going to make after renaming the variable is getting rid of these curly braces and putting in a bracket around name, and we'll do the same for artist type and for the quote. Get rid of all the curly braces around. And now, instead of using a comma, we will assign the value of the artist to the name. And we'll do that for each of these scenarios, for name, artist type, and famous quote. Make sure that we close all the brackets. Now, while syntax-wise the differences look small, the advantage here is that we're working with indices of the new objects, indicated by the brackets. So as a result, these initializers can now be used for any object supporting an indexer, like a generic list. So for example, we can simply define an array and instantiate that with name and artist type. And then let's set up a variable called this array list and instantiate a new list with the type of string and place our array in there. And here is where the initialization begins. So we can put an indice of 0 and have Al Pacino assigned to it. And right below, we can set Mafia assigned to the indice of 1. And then we finally close everything off by ending it with a semicolon. And actually that should be an A. It's Mafia, not Mafio. So now let's iterate through our collection. A shortcut to set up a for each real quick is just to type in for each and hit the tab key and replace the name of collection with the appropriate collection name. And we will write it out to our console. So when we run it, there you go. Al Pacino, Mafia. At first glance, this doesn't seem like a huge change, but the great advantage is that we can now use this for various types of objects that support an indexer. And this could be very useful if dealing with JSON objects. So in this video, we learned how C#6 has added a new syntax to object initializers, allowing you to set values to keys through any indexer that the new object has. And that's essentially what index initializers are. In the next video, we'll be covering the topic of exception filters. So I'll see you there. In the previous video, we learned about enhancements related to index initializers. In this video, we are going to learn about the enhancements related to exception filters. Let's go ahead and start with a demonstration. There may be times you might be handling exceptions and need to perform specific actions based on the type of exception. Well, we can easily state what to do by caching a specific type of exception. For example, if we scroll down here, we can change this to an argument exception, a file not found exception, or anything that is relevant. But what if we cared about doing something based on one of the properties of that exception, like the message content? Well, in previous version, you'd have to write a condition that checks the property, such as in this case, if ex.message equals whatever value we cared about, and then take the action that we needed. But in C#6, this situation has been simplified by being able to use the when keyword in an exception filter. Let's go ahead and demonstrate how. Why don't we start off by copying everything that's in this test async and catch finally method and pasting that in our test exception filters method. And we'll go ahead and modify it from this point on. What we can do is use a when clause that will check the property of the exception. So in our case, what we want to do is say, if the message starts with the keyword warning, and we do that by saying when, and we'll check the property of message and use the substring property to indicate the start and end of the string, 0 through 7, number of letters in the word warning, and see that it equals warning. And if that's the case, we will, let's cut this out, and just do nothing because it's just a warning. But if that's not the case, then we'll essentially do what we originally had and implement this line of code here to log our data. One thing to note is that whatever expression you use with the when clause has to return a Boolean value before it decides to drop into the exception or continue down the path of another catch clause. So we just learned about exception filters. These exception filters are preferable to catching and rethrowing because they leave the stack unharmed. If the exception later causes the stack to be dumped, you can see where it originally came from rather than just the last place it was rethrown. Coming up next, enhancements related to the await keyword, specifically related to catch and finally blocks. I'll see you there. Hi everyone. In the previous video, we learned about using exception filters. In this video, we are going to look at enhancements affecting the await keyword and how we can now use it within the catch and finally blocks. Let's go ahead and start off with a demonstration. C#5 introduced the ability to run asynchronous methods using the await and async keywords. However, there were some limitations when handling exceptions because you couldn't use it in a catch or finally block. On my screen, I have a copy of Visual Studio 2013. And as you could see, the compiler complains that you cannot await in a catch and finally clause. But in version 6, you can. And the most common reason you'd even want to implement this feature is if you're logging errors. That's something that might take a few seconds, and you don't want it to freeze up the UI. Let's give it a try demonstrating an approach to log with async prior to 6.0 and then with the new version. The first thing I'm going to want to do is to create a method to log our data. So I'll start off with private static async, and we'll specify task, and we'll call this log data async, and the parameters will be a string, details, and an exception, ex. Okay, and within here, I'll say using, and I type in the word using, and again, just hit the tab key, and it'll set up the condition for me. Let's say we'll check a variable called this file, hit append text. It doesn't recognize file, so I'll hit Control period to bring that into the namespace system.io. So now if I remove the period and hit period again, I'll get my methods that I care about. append text, and the text we'll append is, let's just call it issues log. And right below is where we'll use our await keyword and say await this file. We'll invoke write line async, and within here, with a little string interpolation, we'll specify details. And then actually exception should be EX, not ED. So it makes more sense. So I'll check to see if the exception is null. And if it is not null, then we can return the value to string and finish off with a semicolon. Okay, so that's it for our logging method. So now let's go ahead and put this to use by going to our test async method and demonstrating the old approach. I'll start off by defining an exception, set it to null, and then set up a try clause. I'll type in try, hit tab, Visual Studio sets it up for me, and here I will throw a new exception and we'll say something went wrong. And right below here I will add EX to set that as a variable for exception on line 29. Back on line 24, I'll make sure that's one equal sign so it doesn't complain. And on line 31, now I will say exception is equal to EX. And this is where we had to do the workaround. Because we can't use await in the catch block, we had to do a hack, like creating an if condition to check if exception is not null. And at this point, we could use await and enter in log data async and state something like problem description, and then pass in our exception. That's what we needed to do. Why don't we go ahead and comment this out though, and do this with C#6 new feature where we're able to use async within the catch block. What I'll do is I'll copy our try clause and paste here. And since it's already commented, I will highlight and uncomment. I want to make sure I get this exception variable that I defined. Okay, so all we need to do is cut our await statement, get rid of this if block, and in our catch clause, highlight over this, and we could write over it, we could paste over it, and then change exception to EX on line 43. And also, while we're here, let's demonstrate how we can use await in a finally block. What I'll do is I'll add await, log data async, and since what enters in the finally block is going to be done after everything else is completed, we can say logging is complete and just pass in null here. Okay, so now let's go ahead and right click on our project file and select open folder in File Explorer, navigate to the bin directory and then the debug, and now you'll see that I have an issues file here. That's from previous tests that I've done. I'll delete that. Okay, so it's not there. And I will go ahead and run the program now. And when I go back to the folder, there's the issues log that it created, and it has the problem description. And this was all done asynchronously. Now, there's a lot going on behind the scenes when we do this, and that's okay because the compiler is responsible for handling all that work. So just keep in mind that you can now use this await feature within the catch and finally blocks, so you don't have to do the workaround or hacks that we've had to do before in the past. So in this video, we learned that we can now use the await keyword in catch and finally blocks. This eliminates the need of hacky workarounds that were needed in C# version 5 and earlier versions. Coming up next, enhancements related to extension add methods in collection initializers. I'll see you there. In the previous video, we learned about enhancements related to the await keyword. Now we're going to go ahead and learn about some enhancements related to extension add methods in collection initializers. Let's go ahead and launch Visual Studio and start with a demonstration. C# 6 now observes extension add methods. I've gone ahead and created a custom object. So in Visual Studio, you'll find an initialized collection inside the method test extension add methods. So why don't we go ahead and click on Singer Collection, right click and go to definition. And let's break down what's going on in this Singers Collection class. We have a Singer Collection class implementing IEnumerable of Singer, which means it needs a strongly typed version of getEnumerator. And this implementation of getEnumerator, which you could see here on line 16, will return us a collection of IEnumerator of singers. IEnumerator is a pretty significant interface in C#. It is what allows us to iterate through a collection. Without it, we couldn't use the for each statement, which depends on it. Well, this interface allows us to use IEnumerable.getEnumerator, which, as the name implies, returns an IEnumerator. And lastly, we have a method to add singers, which returns current singers in addition to the ones that were just added. Now let's navigate back to the program file. In this case right now, we have access to the singers collection. But what if we didn't? What if we didn't have access to this collection, this type, and for whatever reason it didn't use the add method, but some other term? We'd have to find some workaround in order to deal with that. For example, if we change in the singers collection file, add to put, and saved it, and go back to the program file, the compiler will complain. It'll complain because it doesn't recognize the word put by default, but it does for add. However, in C# 6, because we're now able to use extension methods, for cases such as this, we have a neat little workaround to address this problem. So all we need to do is come down to create an extension method. So let's make sure we go to the right location. We'll want to go to the second to the last curly brace. All I have to do is start off with a static class, and let's call this Singer Storage Extension. And we'll have a public static singer, and here's where we use add. And then when we're dealing with extension methods, we use the keyword this, and we'll specify singer collection and add a singer called another singer, add the curly braces, and right below add collection, and now we can use put and add another singer passed in, and then return this other singer. There you go. Our compiler no longer complains. So if we were to now debug, let's put a breakpoint on line 22, and we click Start at the very top. If we go ahead and step over, you'll notice that in our collection, when we hover over singer collections, we have a count of 4. We have the first being Jay-Z, second Julio Iglesias, and then the third James Brown, and fourth being Tom Jones. And if you didn't catch it the first time when we were in our singer collection, we already had Jay-Z and Julio Iglesias there as default. And then later on, we added James Brown and Tom Jones as singers. And that is it with the ability to use extension add methods. So we covered quite a bit in this section. We covered C# 6 features that involve the new using static clause, expression bodied function members, auto property, null conditional operators, string interpolation, name of expressions, index initializers, exception filters, enhancements with the await keyword, and then finished off with a discussion of extension add methods and collection initializers. There's more documentation on GitHub, so you can actually go to this URL or simply just go to Google and search for GitHub C# 6. So if I were to come to Google, just typed in GitHub C# 6, ideally near the top, you should see new language features in C# 6, and it has a quick summary of all the key features that we covered. And if anything changes, theoretically they should update this documentation here. Coming up in the next section, we will be building a mortgage calculator using some of the features that we've just learned about, in addition to some other core classic features of C#. I'll see you there. In the last section, we took a look at some of the new features in C# 6. In this section, we will be building a mortgage calculator in WPF. But in addition, we'll be covering some other topics. So the section itself will break down such as building the calculator UI, then writing the calculator logic, then doing some refactoring, and then hitting some topics such as delegates, generics, lambdas and LINQ, and database types such as SQL versus non-SQL databases. So let's go ahead and get started with building the calculator UI, which is going to be using Windows Presentation Foundations. So in this specific video, we'll be focusing on creating the mortgage calculator UI. Okay, to get started, before I start drawing any elements for the UI, I want to set up my realty and make sure I have space to work. So why don't I shorten the Solution Explorer pane and then get rid of the output by unpinning it. Okay, now we can continue by adding some labels to start marking some of the areas of our mortgage calculator. On the left-hand side, I'll grab a label and drag it onto the screen, and we'll call this mortgage calculator. And sometimes instead of like re-dragging the same element, I like to just copy and paste. So I actually highlighted the mortgage calculator and then just did Control-C and V, and then it actually duplicates it. And if you look at the grid in the XAML window, you'll see that there was a duplicate here. Now afterwards we can come in and clean this up and correctly name them, appropriately name them. But for now, let's just go ahead and get the labels completed. So I'll call this label here monthly cost. What our mortgage calculator is going to do is basically give us the monthly payments when you input a mortgage amount, an interest rate, and period. So those are the items that we're going to put on the screen. I'm going to copy and paste this 3 more times. And actually 1 more. And we'll call this the mortgage amount. That's pretty cool that it has a spell check right there. What will we do without spell check? We'll call this interest. And when I click on here, the way that I get the focus is either by clicking on it softly 2 times or by simply hitting F2, and then that should put focus on the text. This will be the period. And down here, this will be the monthly payments. Okay. Now let's go ahead and add in the text boxes where we'll put in our values. So I'll drag in 1 text box here under mortgage amount. And then once again, I will copy it and paste it 1, 2, 3 times. We're going to have a text box for the interest, a text box for the period, and then a text box for the monthly payments. And then we can go ahead and add in a button that will do the calculation. So I'll drag a button here. I'll hit F2 to get focus, and we'll call this calculate. Now what I'd like to do is I don't want to see the values that's defaulted as text box in here. So I will just get focus on this text box and just hit the delete key to remove that. Alternatively, you can come to the XAML and clear it there. For example, if I come to mortgage amount, I can go under text here and just hit delete. So the actual field is called text box copy 1. So I could just delete that. That actually removed the one from the period. But do that for text box copy 2. That removes it from the interest. And then we could do it for text box, our original one. And that removes it under mortgage amount. All right, to make this look a little bit easier on the eye, why don't we go ahead and add in a border and then put that around the title, mortgage calculator. And for the label of mortgage calculator, what we can do is increase the font. So what I did is I put my focus on the label in the XAML, and then that automatically put focus on mortgage calculator. And so now I'm able to come to the properties, and if I choose text, I have my option to increase the font, and we could expand the Solution Explorer a little bit to hit the drop down arrow, and let's say we bring it up to 24. That looks pretty decent. Let me just position that a little bit. And there we go. So we have our mortgage calculator. We're going to be calculating the monthly cost. We have our mortgage amount, our interest rate, our period. We're going to align these a little bit to make them look a little bit better. And then we are going to be hitting the calculate button in order to get monthly payments. Okay, let's go ahead and save this and see how it looks when we run. Let's build, make sure that there's no odd errors. Looks good. And let's click on start. And there we go. Now this little section here with these icons shows up as a result of us running in debug mode. If I were to actually stop the debug mode and go to debug and start without debugging, then we'll get our window the way that we expect it to look. All right. So that is it for setting up the UI, and what we can do before adding the logic is set up our XAML to make more sense. That is, to change the variable name to what they are. So for example, for mortgage amount, if I click on here, I'll get the focus on the XAML. We should really be changing this to something that makes sense, like amount. And likewise for interest. If I click on interest, puts focus on that text box, then I can come here and call this interest. So I'm going to go ahead and clean this up. You can go ahead and do the same in the interest of time. And now we have it. So I went ahead and updated my labels and text box names. The convention that I used for the labels was just doing LBL underscore and then the appropriate name. And for the text box, I could have done TXT also, but I decided to just keep it straight by just naming the variable amount, monthly payments, period, interest rates, and then also a title for the button. So that should be it. We can run it again by hitting debug, make sure that it starts without any issues. And it does, and that is it for the UI. In this video, we set up the mortgage calculator UI, but coming up next, we'll be writing the calculator logic, so I'll see you there. In the last video, we took a look at setting up the mortgage calculator UI. In this video, we're going to be writing the logic, so let's go ahead and look at the demonstration. Okay, so the first thing that we're going to want to do before adding any logic is to go to the main window .xaml.cs file and then recognize that we only have the main window method in there. And so what we'll want to do is navigate back to our XAML file and just double click on the calculate button. That'll create a button underscore calculate click method. And this is where we're going to be putting the majority of our logic. However, the very first step that we want to take is to create the variables that we're going to use. We're going to want one for the amount borrowed. It's going to be of a type of a double. The interest rate, which is also going to be a double. And then the mortgage period, which will be an integer. The next thing we'll want to do is to obtain the values and parse them. So what we'll do is assign the value of amount borrowed. That's taken from the amount field from its text property. Now it's complaining because it says it can't implicitly convert a type of string to double. So what we want to do is simply parse it to an integer and then convert that into a double. The next thing we'll want to do is set a variable that we could call result, which will be of a type of a decimal. And what we need to do is take in our interest rate, which will be written in as a string, but we want to parse it into a decimal. So what we can do is use the property of try parse and then take in the text property of interest and the resulting value of the parse. We put that into the result variable, and with that we take our interest rate and assign the value of result, but as a double. And what we do is put it in an if clause. So if the result successfully parses, place it into the result value, and then make it a double and assign it to interest rate. All right. The next thing is our mortgage period. And what we're going to do is assign that the value of what is entered in our period field, which is parsed into an integer. Okay? So all we did is just take in these values and parse them accordingly. The amount borrowed and the interest rate both needed to be a double, and the mortgage needed to be an integer. So they were all originally strings. We parsed them and now have the correct type for those values. Now the next thing we need to do is to calculate the mortgage. And we're going to do that so we can state monthly payments is equal to, and we're going to call a method that's going to do the calculating. And that method is going to be called calc mortgage. And we're going to pass in 3 variables. We're going to pass in the amount borrowed, the interest rate, and the mortgage period. Okay, so it's complaining since this method currently doesn't exist. So if I do control period, I can go ahead and generate this. Now calc mortgage, I'm going to want it to return a string, so let's change this to a string. And the first thing that we're going to do is change these variables into a couple of simple letters so that it's easier to put into the formula that we're going to use. So for example, the letter P will be amount borrowed. The letter R will be our interest rate, but we're going to convert it to a monthly interest. So that's going to be a separate method that's going to do that conversion. So it's going to be convert to monthly interest rate, and that's going to be R. And the last variable will be N, and that's going to be calling a method called years to month. And this is just going to give us the number of months that's the equivalent to the years that was entered. Okay, and the reason I'm using these letters P, R, and N is because I'm using a formula that I found on Wiki, and those were the variables that they use. If you were to go to Google and type in Wiki calculate mortgage, you should get an option for mortgage calculator. That's part of a Wikipedia page. And when you scroll down to monthly payment formula, this is the formula that I'm using right over here. And so they use these variables, R, N, and P. R for the monthly interest rate, N for the number of monthly payments, P for the amount borrowed. Okay, so let's have this formula here to the side and adjust this window so we could see monthly payments. And actually, when we generated this method, the reason it had text box is because monthly payments should actually have a text, which if that was the case, it would have had string, not text box. Otherwise, it was just showing as a text box, and that's why it's a text box as the return type for calc mortgage initially. All right, so let's go ahead and plug in this formula. We are going to be returning the mortgage rate to a variable of C. And what we want is to multiply the rate times the amount borrowed. So let's enter in R times P, and then we're going to multiply that by the rate plus 1 to the nth power. And the way we do that is by adding a multiple sign, and we use the math property for power, and we'll have two parentheses because we're going to have in the inner parentheses 1 plus R, and the way we raise it to a power, the power property takes in an x value and a y value. Both are doubles. And the y is what we are raising it to. That's the power. So that is where we put in n. And then we're going to close the parentheses for all of this. Let's make sure that the numbers are correct. And then we will divide it. So what we have is the rate times the amount, the interest rate times the amount borrowed, and then we multiply that by the total of 1 plus r to the nth power, 1 plus r to the nth power. All right? Then we divide it by 1 plus r to the nth power minus 1, and that would be as such. And because we close the parentheses, we want to add one more, and that looks good. The last thing that we want to do is with the value that we're returned is to make sure that it's a decimal. Okay, and that's how it looks so far. Now when we're returning the value, we're going to use some string interpolation. So we're going to have this in parentheses and start off with the $, and then we're going to return something. Okay, so this first $sign is just to indicate that we're going to be using string interpolation. Now we could simply just return the value as C, but that's going to be a decimal value. What we want to do is round it off. So the way that we do that is by using the math property to round, and then we'll pass in C, and then we want to say round it to the midpoint, and away from 0 basically means to the whole number. And the last thing that I'll add here is a $sign. And this $sign is actually part of the string. That's to show that it's a dollar figure. So if it was $50 if it was the value was 50 that it was returning, it'll say $50. The last two things that we'll do is generate these two methods. Convert to monthly interest rate, and then generate this method years to months. For years to month, we're simply going to be returning an integer, and this is going to be the years. And for convert to monthly interest, we're passing in a double, and we are returning basically a percent divided by 12, and like that total is divided by 100, and the name of the variable that we're passing in is percent. And right here, interest is complaining, and that's simply because the variable name is interest rate. Okay, so now if we get rid of this formula here and maximize our window, and we're to try to build, let's make sure it builds okay. Let's run it. Debug, run without debugging, and our window should pop up. Let's go ahead and test it and put in 100,000 as a mortgage amount, and let's say the interest rate is 3.92 and a period of 30. If we calculate it, $473. That seems to be right, and we could actually verify that by going to a mortgage calculator. And that's actually the default with Google's mortgage calculator. And there you go, $473. And just to show that if we change this, it actually updates right away. All right, and that is it for adding the logic. So in this video, we just saw how to write out the calculator logic. Coming up next, we're going to be doing some cleanup on the code and refactoring. I'll see you there. In the last video, we wrote the logic that was required for the mortgage calculator. In this video, we're going to be doing some cleanup and some refactoring. So let's go ahead and take a look at that. Now, a few things we can do to clean up the code is, one, to right-click on the using statements and basically get rid of all these statements that we're not using. And then, because we're using C# version 6, instead of having to specify int 32 or decimal over here, we can use the using static clause. We can simply say using static system32, and then now get rid of this on line 25 and then on line 31. Okay, now ideally we could have done the same thing for decimal, but it should be either or right now, because if we were to remove decimal, then we would get an ambiguous message, because decimal also has a parse method. So then the compiler wouldn't know which one to use, whether to use the parse for decimal or the parse for int 32. So therefore we leave decimal alone. If we go down, what else can we use this using static clause for? There's math, and there's also midpoint rounding. So why don't we do the same for those? Using static system midpoint rounding, and using static for system dot math. Now we can get rid of this on line 48, and then on line 46 get rid of our math reference, and also on line 48 there's another math reference there. All right. Now if we saved, we've implemented some new C# 6 features. Build, make sure everything looks good. And I'll do Control F5 to run. And it looks like it runs without any issue. We'll drop in some variables here. 3.92, 30-year period, 473. Everything still works. The code is a little bit cleaner now. So in this video, we went ahead and did some refactoring and cleaned up the code a bit. Coming up next are some topics that we're going to hit that I find very important to know when you're building applications in .NET. And the first one we're going to hit it off with is delegates. I'll see you there. So in the last video, we wrapped up our mortgage calculator by doing some cleanup and refactoring. But in this video, we're going to go ahead and start by hitting on a few topics at a very high level. The first being delegates. So let's go ahead and start off with a demo. Okay, so before I demonstrate how to add a delegate in our project, I want to just point out that I modified the code, and this should be reflective in your exercise file, with having default values for the mortgage amount, interest rate, and the time period. So let's navigate onto the C# backend portion. And when adding a delegate, the first thing that we're going to want to do is basically identify or create the function that we want to point to. And in our case, that is going to be the calculate mortgage function that we're going to use. Okay, so we're identifying that this is the function that is going to be pointed to. The second step is to define the delegate itself. And we can do that at the very top of the file above our class. And a delegate looks just like a function with the exception that it has the keyword delegate. If we were to remove this and take a look at it, you'd think that it was going to be a function. It's got a signature with parameters being passed in, a return type. We don't have our curly braces though with content inside it. But we do have this delegate keyword in this particular case. Calculate mortgage delegate is the name of this delegate, and it has to have the same signature as the function that we're going to be pointing to, which is calculate mortgage. It has the amount borrowed as a double, the interest rate as a double, and the mortgage period as an integer. All right, so for the third step, this is where we will create an instance of the delegate. And we can navigate down to the line right where we're calling the calculate mortgage. And what we'll do is comment this out for now. And we will create an instance of the delegate. Calculate mortgage delegate. New calculate mortgage delegate, and we will pass in our function name, which is calculate mortgage, not calculate mortgage delegate. And now we can add what we had in the previous line for monthly payments, with the exception of using the delegate and passing in the parameters that are expected. And that is it. This is now going to use this delegate, which with this instance, having instantiated an instance of it, now going to call this function and pass in the parameters that it expects. So let's build to see if there's any errors. It looks like it's good. And let's run it. We'll calculate, and everything looks good with the delegate that we're using. So in this video, we had a very high level demonstration of delegate and talking about what it is. So with that, we can move on to our next topic, which will be generics. I'll see you there. In our last video, we talked about delegates and what they were. So now we're going to move on to generics. Let's go ahead and start off with the demonstration. So generics allow us to write methods and classes that are decoupled from their data types. And they're often used in collection classes. Like if you've ever seen something like this, where you use the word list and then specify a type, such as a string. But let's look at some code and dive in a little bit deeper into this, okay? Below here, I have a tester class, and it's pretty straightforward. The method inside it is called isEqual, and it takes in two parameters, two interest rates, and then compares them to see whether or not they are equal and returns that Boolean value. Okay, so let's go ahead and make some use for this method. I'll drop in some code. The first line is basically passing in two parameters and invoking the isEqual method, and then just writing out whether or not, if it is true, it'll say yes. If it is not, it'll say no. And obviously 2 and 3 are not equal. So when I run it, we get an output that says no. Now, I mentioned generics allow us to write methods that are decoupled from their data types. Right now, this is tightly coupled. What I mean by that is if I were to change this data type to a string of 2 and a string of 3, the compiler is going to complain because it's expecting an integer on line 20. So how can we change this? Well, one way is to change int to object. And because all types in .NET Framework inherit from object, behind the scenes, there's some conversion that happens. It will take any type that it needs to convert and change it to a reference type. So right now, the compiler is not complaining because it knows how to handle string. And also, if I were to remove it and put back the integer 2 and 3, if I put back both of those integers, the compiler still doesn't complain. And the conversion that's happening here is that it's taking this value type of 2 and converting it in the background to a reference type of object. And that's actually called boxing. Boxing and unboxing, when you convert a value type to reference type or vice versa. The bad thing with that is that it takes a performance hit. It's not an efficient thing to do a lot of boxing and unboxing. So we don't want to do that. The other negative thing about this approach is that I can now pass in an integer and also a string. And it wouldn't make any sense if I passed in 3 like this, or if I typed in 3 to compare 2 and 3. But yet the compiler's not complaining. So the way that we want to address this is by using generics. So what we can do is specify that we want a specific type of T. And actually you could use any letter, but using T is a convention to stand for a type. And then replace object with this T. And when we're using generics like this, instead of using the equal signs to do a comparison, we have to use the property equals and then pass in the value that we are comparing it to. So interest rate 1 has a property of equals that we can invoke and then pass in interest rate 2. And at the very top of our method, what we need to specify now is 1, we'll see that the compiler is complaining because it knows that it is expecting a type to be of the same, and right now these two are not the same types. So let's change this back to 3, and so the compiler stops complaining. However, what we need to specify to make full use of these generics is to indicate the type that we want. So we want to say that is of a type, that it's a type of integer. And there you go. Now, if we were to try to change 2 to a string of 2, it will complain. Also, let's make this a string of 3. It complains. Why? Because it's expecting an integer. So let's undo these and run it. See if we still get the same result. Does 2 and 3 equal? And no, it does not. And of course, if we were to change this to 3 and 3 and run it, it returns yes. Now, the other thing that I'd like to note is that these generics do not necessarily have to be only at the method level. You can also specify it at the class level. So we can remove this T here and indicate that the whole class is expecting a specific type. So now, if we go to the top of our main method, you'll see our compiler is complaining because it doesn't expect us to specify integer after is equal, but rather right after the class name. And this effectively does the same thing and will render the same result. So when we run it, once again, it returns yes. And now by having done this, we've decoupled the class from the data type. And what we had before, we had decoupled the method from the data type. And there's no boxing or unboxing going on, so performance is at its optimum. In addition to the fact that it is strongly typed, so we can't mix and match types like we did when we were using objects. It would complain, the compiler would complain if we change one type to string, which is not what the compiler is expecting. All right, and that's it. So in this video, we talked about generics and gave a simple demonstration. Now we can move on to our next video, which will be covering the topics of lambdas and LINQ. I'll see you there. So we just finished talking about generics in our last video. Now we're going to move on to the topics of lambdas and LINQ. So let's go ahead and start with a demonstration. A lambda expression is an anonymous function that you can use to create delegates or expression tree types. By using lambda expressions, you could write local functions that could be passed as arguments or returned as the value of function calls. To me, they're basically simplified versions of anonymous functions. Let's go ahead and look at some code for an example. Right here on line 19 is an example of an anonymous function. Now let's go ahead and change this to a lambda expression. First, we won't need the delegate keyword, so we could get rid of that. And then we could get rid of the curly braces and this return statement, and instead use the goes to symbol. And then towards the end of the statement, get rid of the semicolon and the last curly brace. So now it's a lambda expression. It's a little bit more straightforward and easy to write. Now let's go ahead and run it and make sure that it works correctly. This syntax simply returns the home buyer from this list above on line 13 and returns a record whose ID is equal to 11. So when I run it, I get the record with ID 11, which is Jimmy. Now when we look at the lambda expression, there's two major parts to it. There's the input parameter, which is home buyer and B, and then there's the expression, where the ID is equal to a specific number in this case. The other thing that's cool about the lambda expression is that you don't even need to specify the type. So we could get rid of home buyer, and the reason why this works is because it will be inferred. And you could tell that through the IntelliSense by hovering over find. So we could run it one more time, see if it works, and it does. Another thing that I'd like to note is that the letter B that I chose to use here could pretty much be any letter. That is up to you. But it just makes sense to use a letter that's kind of reflective of whatever the variable is. Lambda expressions are particularly useful when we're dealing with LINQ queries. LINQ stands for Language Integrated Query. And it basically enables us to query any type of data store, be it a SQL Server database or an XML document or an object in memory or whatever. And the great thing about it is that it allows you to use the same syntax to do your query no matter what the data store is. So for example, we have our object here, a list of home buyers, and let's say we wanted to get a count of the number of names that begin with the letter M. So we can set a variable called count and say buyer list, invoke the count property, which is a function of LINQ, and then use some lambda expression and say X, or I'll just say B in this case, B goes to, and it's okay that I use B here because even though we use B up here, the scope is within these parentheses, so there's not going to be any conflict for me to reuse it. B and we want the name property, and say starts with the letter M. And then we'll write that out to the console. And we get the count is 2, which is correct. There was Matt and there's Margie on line 14 and 16 respectively. Now there's a lot to LINQ and there's a lot to Lambdas to really get a good, solid, firm understanding of them, but it's important to know the relationships between them, and that's why I wanted to choose a very simple, direct example to connect the dots between LINQ, Lambdas, and even anonymous methods, which I didn't really go into, but it is the origin of where Lambdas came from. And the better you understand the relationships, the better you'll be in a position to leverage their features when you're coding more complex programs. So we've just discussed Lambdas and LINQ, which are often used for querying databases. So let's go ahead and move on to the topic of SQL versus NoSQL databases. I'll see you there. In the previous video, we talked about Lambdas and LINQs and what their purpose is as it relates to databases. In this video, we are going to be talking about two different types of databases, SQL versus NoSQL. That will include some example products of each and also the key differences between them. So first of all, SQL databases is a relational database management system, often referred to as RDBMS. And the data there is generally stored in tables, which are a collection of related data entries and consist of columns and rows. However, non-SQL databases provides a way to store and retrieve data in a very efficient manner without having to use tables. Some examples of products for SQL databases are DB2, MySQL, Oracle, SQL Server, and for non-SQL, there's ArcLogic, MongoDB, which is extremely popular, OrientDB, and QuizX. Now let's talk about some key differences. Now, under SQL, RDBMSs are generally designed to scale up. So that means to improve their performance, you may just need a bigger box. And that tends to have some limitations. However, with NoSQL, they're designed to scale out. So in order to improve the performance, it's just a matter of adding more boxes, not just getting a bigger one. The second key difference between SQL and NoSQL, SQL handles structured data. So that is, different documents need to use the same fields. They need to adhere to a specific structure. However, with NoSQL, it can handle non-structured data. So a specific document does not need to have the same field as another document. There's a little bit more flexibility there. Another key difference with SQL is that it handles autonomous transactions. So a series of events might need to occur before a transaction is considered successful. It's either all or nothing. Whereas with NoSQL, that's not always the case. It's not so absolute. And the last key difference is that for SQL, there's the concept of impedance mismatch, which means that it stores data differently in the database than it would actually be reflected visually on a class diagram. However, with NoSQL, it's a little bit more intuitive and reflective of your code or class diagrams. So a few things that I wanted to point out, the first being, one is not necessarily better than the other. The thing to keep in mind is that it's really going to depend on your situation. So, which brings me to the second point. You need to understand the pros and cons that each option, whether you're using a relational database system or a NoSQL system, what those benefits are that each bring and what are the cons of each, and then assess that compared to what your architecture requires. And on top of that, not only be able to understand that, but then to be able to articulate why you would have to prefer one than the other. Because it doesn't make any sense if you know what the right thing to do is, but then you're not able to convince others on your team for them to fully understand the benefits that you're trying to explain, and then they end up going with the wrong decision. And this pretty much applies to really anything that you want to share with your team. But this is an example that I definitely wanted to emphasize because choosing the right database architecture is a crucial component whenever you're being involved with architecture. So in this section, we went over quite a bit. We went ahead and designed a mortgage calculator, the UI of it, and then later on built the logic, and then followed up with some refactoring, implementing a few C# features that we learned earlier on. Then we talked about the relevance of delegates, followed by generics, lambdas, and LINQ, and then finished off with a talk about SQL versus non-SQL databases. Coming up next, a discussion about deployment and hosting. I'll see you there. Hi everyone. In the last section, we built a mortgage calculator and touched on some important programming concepts. In this section, we're going to cover some changes that's happened with deployment and also touch on the topic of hosting and then wrap up the course. Specifically, we're going to briefly talk about ASP.NET Core and its ability to be cross-platform. Then we'll move on to talk about GitHub, and then finally the best approaches to coding and keeping up with C# and .NET. So for now, let's kick it off with .NET Core and its ability to be cross-platform. There's two specific things I'd like to show you in this video. The first is how Microsoft is working to develop the new .NET Core to be able to successfully deploy self-contained applications. That is one way they define it as being cross-platform, because you can be in Visual Studio on Windows and should be able to deploy an application so that it can run on a separate environment. The second is that you can also just install .NET Core on a separate environment such as Linux or a Mac, and we're going to go ahead and demo that. But let's first talk about the concept of a self-contained deployment. ASP.NET Core is a free and open source web framework, and it's really the next generation of ASP.NET that's developed by Microsoft. Now, one of its main features is the fact that it's open source and then also cross-platform. There's a lot more to it, but we're going to be focused on the fact that it's cross-platform, and that's what this demo is about. Right now, I just brought up a simple web application that I had created just by going to File, New, Project, and going through the steps that you would to create a simple web application. I chose Web and then chose ASP.NET Core. Once this application is set, theoretically we should be able to publish this so that we could run it on a separate environment. And the way that you do that is by configuring your project JSON file. So what I did was I first added the runtimes that I wanted to give me the options to deploy to. And that is in the section here for runtimes, and I added osx.10.11-x64. And then there was one other line that I needed to remove, and I'll show it to you from a different application under dependencies where it says type::platform. And what that does is it makes sure it includes all the dependencies that it needs. So there's a little bit more overhead, but it has everything that it needs so that the environment that you're going to run it on does not have to have .NET installed. So as you can see at the very top here under dependencies, I don't have that line. So now if I try to publish by right-clicking on my project and then choose Publish, the first time you do this, it'll have you create a profile. I already created a profile called Test6. If I go to Settings, I'm able to choose my framework and runtime. And when I publish, it should publish the files that I need in order to run it on a different environment. Now, the thing is, this is still kind of a work in progress, because it was just a few months ago that the approach to doing this was using another concept called DNX, and things are changing there pretty quickly. So this is just something to kind of keep in mind. I would not try to use this in any way for production, because they're still working out the kinks. Because when I published it, it did not come out the way that the latest documentations described it. So it is something that they are working on, and it is going to be very cool when it's finally done and said. However, having said that, the other way this new framework is still considered cross-platform is by the fact that you can install and code .NET applications on a Mac or a separate environment. So let me go ahead and show you how you would do that. There's two ways. One, if you go to Microsoft's site, there's some documentation that you can follow. If you go to Microsoft/net/core, there's some steps that you can follow to install a package manager called Brew, and then install some software that will set your paths and everything that you need in order to be able to install the .NET environment. Okay, so you can follow this. Many developers have their own ways of doing this because, like I said, it's kind of still in the works, and some approaches are better than others, really depending on your experience and what environment you're most comfortable with. I chose to use Yeoman, and that's going to be what I'm going to show you. But it's really up to you. You can go ahead and follow this or the steps that I'm about to show you. But either way, in the end, we're going to have like an environment on a separate platform that's non-Windows that you can run a .NET application. So let's go ahead and start by showing how to install .NET Core on a Mac. The only prerequisite is that you have Node and the Node package manager installed. Okay, so the first thing that we're going to want to do is go to our terminal. So we can just go to Finder and type in terminal. That should bring up our terminal. Afterwards, we can go ahead and create a directory that we're going to be working in. So let's type in make directory and call it my web app. Alright, and to install Yeoman, we can simply type in npm install -- global yo. Let it run through. Now you want to look at the documentation if you come into any type of errors, any permissions while it's installing. Sometimes the system needs to be configured. Okay, looks like it went through. And let's check the version. 1.8. Looks good. After you've installed Yeoman, you need to install a generator. Yeoman uses the concept of generators. So we'll need to type in npm install -g generator -ASP.NET. This might take a few minutes, so I'll go ahead and skip ahead. Alright, now it's complete. So the next command that we're going to want to enter is yo ASP.NET. Alright, great. Looking good so far. Okay, so now ASP.NET installer is going to be asking us a few questions. The first is, what type of application do you want to create? We're going to go ahead and keep things simple and choose Web Application Basic without membership and authorizations. The reason why is otherwise it would add a lot of complexity that we really don't need to address right now. So we're going to go ahead and choose that. Then the next thing it wants to ask is, what UI framework would you like to use? We're going to keep it simple and just choose Bootstrap. And then what's the name of your application? I'm going to go ahead and write my web app. And so now when you are at this state on a Mac, this is what we mean by being cross-platform, because we essentially are at the same state that you are on a Windows to run the Windows application. So for example, if we were to go to Windows, and I'm going to go ahead and create a basic .NET Core web app. I'll choose Web, and ASP.NET Core Web Application, and it'll be called Web Application 7. I'll create that. I'll select Web Application, make sure host and cloud is not selected. And now, on my right-hand side, if I were to go right-click and open a folder in Explorer, this will allow me to get the path. So I'll copy that. And now I will go to the command prompt. And you can run .NET from the command prompt. So let me change the directory to where we just copied. And from here, I can type in .NET help. And we'll see we essentially have the same commands that we saw on the Mac. We can restore, we can build, we can publish. On either environment, you should be able to type in restore, .NET restore, actually. It will obtain its dependencies that it needs. And when that's done, do .NET run. It does its compiling and begins running, and it tells you what host to look at in your web browser, localhost 5000. So at this point, I can bring in a web browser, enter in localhost 5000, and it brings up our application, whether we're in Windows or on the Mac. Now, if you are on the Mac and you ran into any type of issues installing Yeoman, the website yeoman.io/learning has documentation you would need that steps you through the installation process. And if you come into any type of errors regarding permissions, there's a link here that has some more details on how to handle that. Okay? In this video, we demonstrated how to install .NET on a Mac. Just keep in mind the .NET Core is still evolving. And while there might be a few bugs you may encounter here and there, the changes that have been made have been really great, and the fact that it's open source is another big bonus. So while the effort to become cross-platform is a big undertaking, it's definitely worth the wait. Coming up next, a discussion about hosting with Github. I'll see you there. In the last video, we talked about the .NET Core and its ability to do cross-platform deployments. In this video, we are going to be discussing GitHub. Specifically, we'll be looking at what GitHub is and how it works with Git. So while on that topic, we'll also discuss what Git is. And ultimately, you get a good sense of how people use them both together. So let's talk about what is Git. It's used for source control. Now, source control is also referred to as a version control system. The thing about Git is that we run it from a command line. We control most of its features from, if you're in a PC, a DOS prompt, or on a Mac, the command prompt on there. The way that we track the code is within a concept called repositories. So you can have several different repositories for different projects that you might have, okay? Now, a lot of people get Git and GitHub confused that aren't familiar with it, but GitHub is essentially just a website that you could upload your repositories to online. One of the benefits of it is that it backs up your files. The other benefit is that it provides a visual interface for navigating repositories. So I went straight to github.com, but let me put in a URL that brings us straight to an existing repository I'm familiar with, Ode to Code. That is the repository of Scott Allen. So Git provides this visual interface for some of the projects that he has on. So for example, you see here it says Memflex. So if we clicked on here, then brings us to the folder that has some of the source code, in addition to some other miscellaneous files, such as like a README file. If we click on the folder, then you see much more folders that have, which we can assume would be code, all right? And that's exactly what it is. Some project files and some C# files right here. So that is GitHub. It provides this visual interface, okay? Now, there's also a social aspect to it. For example, on the left-hand side here, you can see that he has 598 followers as of the time of this recording. So people can access your code. You can control it so that they don't see it, but people can have access to your code and see the type of work that you've done. And that's the main power behind GitHub here, because a lot of employers will come here to get a sense of what your coding style will be. All right, so let me go ahead and talk about installing Git. There's two places you can go to install it. One is git-scm.com, and the other is desktop.github.com. Now, the main difference between these two is if you were to go to desktop.github.com, you can download it and it'll set everything up for you nicely. And in addition, it'll provide you a user interface that you can use instead of the command prompt to make changes to your code and compare it and so forth. But the thing is that a lot of employers want their developers to be good at the command prompt. And so that's the approach that we're going to take. And that's why we're not going to use this to install it, but we're going to use git-scm.com and go there. You can think of it like this. When you were in grade school and you were first learning math, they wanted you to learn how to do additions and multiplication by hand and not use a calculator. And that's why we're going to be going through the command prompt, because it's the beginning and it's really important for you to be familiar navigating there, okay? Using the UI could be something that you could do on your own after you've gotten very strong at the command prompt. All right, so with no further ado, let's go ahead and show you. If you wanted to download and install Git, you simply need to go to git-scm.com and download it from here. Over here it says download for Windows. It'll say Mac if you're on iOS. And I'll click that and it will start downloading. And once the download has complete, you can go ahead and run it to start the install process. So I'm going to go ahead and just keep the defaults. Yeah, that pretty much looks like what I want. And I will click next. Use Git for the Windows command prompt. And once the installation is complete, I'll click Finish. Uncheck the View Release Notes first. So now let's go ahead and do a simple demonstration of using Git and GitHub. So if you don't have a GitHub account, the first thing that you're going to want to do is to sign up and create an account. So just complete these fields. Now I already have an account, so I'm going to go ahead and log in. And after an account is set up, what we are going to do to get started is to create a repository. And if you look right over here, we have an option under Welcome to Git to create a repository. And that's what I'm going to do. Now the repository could be named anything. You might want to just put down your name / repository. I'll just call this my repo for now. And I will check right below, initialize this repository with a README, so that this way we can immediately start working with it. It just needs to have some type of content in it. So GitHub allows you to just have it automatically create a simple text file, a simple README file in there when you create it. I'll put in a description here. This will be my first repository. And then click Create Repository. And boom, there you go. You have your first repository. And there's the README file. So now what we want to do is to, on the right hand side, you should see an option for clone or download. What we're going to do though is hit the drop down arrow, and then you'll see this URL. And what we want to click is on the right hand side, copy to clipboard. Now it's copied. So having done that, we can go to bash, your command prompt. I choose to use bash, and I will navigate into my documents folder if I'm not already there. Let me type in ls to see where I'm at, and I am not in my documents folder because I see the folder right here, documents. So I'll navigate into there, cd documents, perfect. And from here, what I will do is type in git clone, and then right click, paste that URL. And there you go, it starts cloning. And basically what it did is copied that repository locally to my computer. So now if I type in ls, we should see a folder called my repo, and there it is right here. Look at that. If we were to go to Windows Explorer, you see it right over here, my repo. Open that content, and there you go, exactly what we saw in GitHub. So now what I want to do is I want to copy some files into my repo, okay? So let's navigate into my repo, because when we're going to do any type of git command, it has to be in the directory that you want the changes to occur. So I navigated to my repo, there I am. I'll type in ls, I see that README file. And what I'm going to do is go into Explorer, and I'm going to go to Visual Studio. All right, now you might not have this on your computer, but frankly it could just be any folder with any file, okay? You can just create a folder called test and put a simple text file in there and use this for the same purpose. But I'm going to go ahead and copy inside this projects folder a folder called test project vs, and all that's in here is a Visual Studio project. Visual Studio, you'll learn later on in the program, is IDE used to create C# applications. Okay, I mean it does more than C#, but that's what I used it for in this particular case. So I'm going to go ahead and copy this folder into my repo. Now I could be doing this also from the command prompt, but all I'm doing is copying a folder into my repo, what we just cloned. Now if we type in list, we see that folder. And as a matter of fact, what I could do is type in git status, and it'll tell us that it recognized that there's a new folder in here that's not being tracked, which makes sense, because what we now need to do is to add it so that Git knows to start tracking this folder. Okay, and the way we do that is by typing git add and then the name of that folder, or if it was just a file, just that file. The nice thing is that the folder could have several files and subfolders, and Git knows to apply the changes to all of them and track all of them. Git add test project vs. Make sure that there's no typo there. As a matter of fact, let's make a typo, see what happens. Fatal, powerful words. says it does not match any files there. All right, so let's go ahead and get rid of that X. By the way I type that in real fast is by hitting the up arrow. It brings you to the last command that you type, the up arrow key. So git add test project vs, and that looked like it worked. All right, it didn't say that it worked, but the fact that it didn't give you any fatal message. So if to verify that it worked, we can type in git status. See, I just jumped hitting the up arrow key a couple of times and it went up to git status. And look at that. It shows in green all the new files and folders that it added on branch master, and it has all this content here. Your branch is up to date. So that's a good sign. Okay. So now, after we add it, the next thing we want to do is to type in git commit. And this is a way for the project to know that it is ready to be pushed up to online when needed. It has to be committed, okay? Because otherwise you could still be just working on these files. Git commit, and I want to add a description. I add the -m. The M means I'm giving it a message. And that's just a description. All right, so git commit and parameter M for a message and adding new test code. I hit enter and that looks good. Let's see what happened. Adding new test code, committer. All right. Make sure everything looks good. Let me type in git status again. Your branch is ahead of origin master by 1 commit. Okay, so it says that it recognized that 1 commit was done, and now to complete that process, it tells me to git push. Right here it says use git push to publish your local commits, and we just committed something. Okay, so let's do as it says, git push, and this pushes everything onto GitHub. So let's go ahead and try that. All right, there you go. Counting objects, did the compression, and let's type in git status again, see what the difference is now. It says, I am up to date. Your branch is up to date with origin master. Okay, looks good. So if we are to go back to GitHub, into my repository, and I refresh the screen, remember this is how it looked before, okay, with just that README file. We hit refresh, and look at that, test project vs. And if I click in here, and here's my description on the right hand side, it's got the subfolders as I expected, and within here, even more code that was in my test project vs subfolders. Looks great. And that is it. So now someone can literally come to this URL here, GitHub Spamproof 2010 my repo, and clone that to their computer. And that's how you will share your files moving forward. After you upload it to Git, following this process that we just did, you will want to give people this URL, so that this URL up here, so that they can come over here and then just get this Git URL and then clone it. Okay? In this video, we had an overview and a demonstration of how to use Git and GitHub. Coming up next, best approaches to coding and keeping up with C# and .NET. I'll see you there. In the last video, we talked about GitHub. In this video, we're going to be talking about some of the best approaches to keeping your skills sharp in respect to coding and staying current with C# and .NET. There's a few things I'd like to mention in regards to staying current. The first is that when we start a Visual Studio, oftentimes there's a splash page that has some current news of what's going on in the community. And it's definitely something that you want to check out every once in a while, because I feel like it's a great way to just start your day by learning something new that you might not have picked up on before. And it's right there in your IDE. I actually used to ignore it when I first started developing, like the first few years. And then one day I just decided to just check out some of these articles, and they're really interesting and very informative. So I would definitely take advantage of that because it's right there on an IDE that you see every day. Another great way to stay current is to listen to podcasts. It's a great way to stay current in a very simple manner when you might be just driving or commuting to work. Now, there's a bunch of different programming podcasts out there, so I wanted to mention a few of my favorite, but you may have some others that you'll discover and then want to follow on your own. But my favorites are Hansel Minutes by Scott Hanselman, Herding Code, which is run by an author and a few of his good friends. The author is Scott Allen, K. Scott Allen, actually. And another one called .NET Rocks, which is run by Carl Franklin and Richard Campbell, two veterans in the .NET community. Something else that may or may not have popped into your mind is as you learn certain skill sets, either from reading blogs or listening to podcasts or watching videos, keep tabs of the authors and follow them on Twitter or Instagram, because oftentimes they make announcements on some things they might be working on that you might want to check into before their course comes out or their next article comes out, or just some small tidbits of information that's really relevant to know. And before you know it, you'll find yourself partaking in the community. And one of the last and most important things that I'd like to mention in terms of staying current is to get used to building your own brand. Because as a developer, you shouldn't just think of yourself as someone that just assume that you'll just always be going to work for someone else writing code and that's where it ends. There's a lot that others can learn from your experiences. So it's a great thing to try to build your own brand by kind of putting your name out there and share your experiences, either by writing a blog or creating YouTube videos of tutorials of something that you might learn. This is really great for a couple of reasons. One, you can end up building a following. Two, you end up reinforcing what you learn by having to actually teach it. So there's a big difference from learning something that you just read and just coded it versus reading it, coding it, but then having to reiterate it in a form that someone else can understand it. And those that do that retain much more information than if you just read something once and did one program and that was it. So never limit yourself. It's a big world out there as a software developer. So in this course, we went over quite a bit. We started off with a .NET overview and then went into some of the new features of the .NET Framework 4.6. Then we followed up with some features of Visual Studio 2015 that just came out, and then talked about what was new in C# version 6. We then created a mortgage calculator, implementing some of these new features using WPF, and then wrapped up with discussions on deployment and hosting. I hope you enjoyed the course. Feel free to contact me on Twitter at RonaldAdolph or on my website, ronaldadolph.com. That's it for now. Take care.